Hi, this is Lab-1 constant velocity motion by using Newton's second law of motion and momentum principle. For a constant velocity motion, we assume that F net is equal to 0 and the momentum principle is equal to delta B equal to F net multiplied by delta T. And in Newton's second law of motion is Vf is equal to initial velocity plus F net slash mass into delta T. When we put F net is equal to 0, then this part of the equation equal to 0 and final velocity will be equal to the initial velocity, and then we get a constant velocity motion. We can also predict the position of the ball by using this equation Rf equal to Ri plus V multiplied by delta T. We performed an experiment on a tennis ball, and by using tracker we can find the motion. We can find the motion of the ball. The whole session is of 0.83 second and is divided into the 25 frames from the 40 frames to the 65 frames. When we play it, we see that the ball will move in a positive x direction, and on the left corner, on the right corner, we form a graph between the time and the x-axis, and there is a values we get from the for the motion of the ball. Now we calculate the velocity of the ball. Velocity is equal to change in position divided by change in time, and these are the value from the tracker, and when we put here we can find the velocity equal to 8.78 meters per second. The mass of the tennis ball is 57 gram, which is equal to 0.057 kg. We construct a computer model for the motion of a tennis ball by using VPython. In VPython we write the 0.057 the mass of the ball, minus 0.02 which is the initial position, and 8.78 which is the velocity of the ball, and the F net is equal to 0. When we run it, we will see that the ball will move in the positive x direction. We form a graph by using the Google spreadsheet between the experimental data and the model data. Here in the graph, the red line represents the model position and the blue line represents the experimental position of the ball. The red line is a straight line because no forces are acting from the surrounding on our system. But in the experimental position, forces are acting from our surrounding. For example, the friction force, the gravitational force. What if the axis is changed? Then what happens? In Python, we simply change in the ball velocity and make it negative, and run the module. We will see that the ball will move in the negative x direction. What does it mean? If F net is not equal to 0, then we don't have a constant velocity. Study this. We simply put back the velocity of the ball in the original position, and we put the value of the F net. Now the force is no longer equal to 0. When we run the module, we will see that the ball is deviated from the straight line. Now the velocity will no longer remain constant. So we conclude that when the F net is equal to 0, then we have a constant velocity motion. I hope you enjoy it.